Welcome to the YouTube channel of Coding Club of RVCE. I'm Naman and we're discussing the solutions to the CodeChef contest Starters 121. The question is split and maximize. I'll explain the question. So we have an array of n integers and we have to find the XOR of all the elements. Let's say the XOR is x. We have to maximize this x and we can perform this operation at most one time. So the operation is choose any of the elements, a single element, and split it into powers of 2. Say I split 13 as 4 plus 4 plus 2 plus 1 plus 1 plus 1. It's 5, negative 13. Yeah. So when I've split 13 into powers of 2, you can see that the powers of 2 can repeat as well. So it does not matter how you split it. It just has to be into powers of 2. Then I delete 13 from the array and append all of these elements to the array. So the final XOR of the array becomes the XOR of the remaining elements and the XOR of all of these elements. So this operation can be performed at most one time, and using this operation we have to maximize the XOR x of the given array. That is the question. Let's see the examples. So the first example is that we have the elements 5, 7, 7. Now what we can do is we can delete 7 and write it as 4, 1, 1, 1. Now when you take the XOR of these elements, it comes out to be 7. 7 has all the bits set. So 7 is this in binary. This has all the bits set, hence the XOR of any kind cannot increase the number of set bits in 7. Therefore, we cannot increase this answer. So this is the required answer. The second test case is 5, 5, 7. The XOR of these elements is already 7. And that is again all the number of set bits. Hence, we do not have to do the operation. The XOR in the previous case, that is 577, was 5 initially, which was less than 7. Hence, we had to perform the operation. The final test case is 0, 1, 2, 4, 8, and 16. Now, all of these numbers can be seen that they're powers of 2. So let me just write them in binary. So there's 16, 8, 4, 2, and 1. When I take the XOR of all of these elements, I can see that each bit in each row occurs only a single time. Hence, the XOR of these elements would be this, which is 31. Since all of the bits are set in this, hence it cannot be further maximized. Notice that the test cases that have been given, the final answer has all the bits set. Now, we do not have to get carried away by this. This is not the case that we have to consider while solving the question. The final answer can also have 0 in some places. So that is something we have to consider and formulate the solution. So let's discuss how to perform the operation and how to choose the element that we must delete and how to split the element. So the question is actually a trick question. You do not have to actually delete an element. You just have to deal with bits of the elements. I'll explain how. So first of all, let's say with the initial elements, we have the XOR value as this. Now, I also need one more thing, which is the frequency of each bit. So let's say this bit occur 1 times, this bit occur 3 times, this bit occur 2 times. I'll fill this out. Yeah. So let's say we have the frequency of each bit as this and the XOR initially as this. You can notice that wherever the XOR is having a set bit, the frequency of the bit is an odd number. This is because only when we have an odd number of set bits, the XOR bit can be set. Okay, so let's try to maximize the XOR value for each bit. When we do that, we can ultimately achieve the highest XOR value. I'll get to the deletion of element part in a bit. So when I see this one, it's already set. Uh, if I were to take this one out, suppose I have an element, I'll call this place as I. So if I have an element 2 power I in the array, I'll pick out this element and break this as 2 power I minus 1 plus 2 power I minus 1. That would give me two of the elements which are having the previous bit set. Now that would uh, decrease the number of set bits, the number of elements having this bit set by 1. So finally, when I delete this element, the number of elements which have this bit set becomes 0, and the number of elements which have I minus 1 bit set increases by 2. So when I do this operation, the XOR value, since the frequency is 0, the XOR value for this bit becomes 0 as well. Now, this is not a favorable condition for us since we have to maximize the value of XOR. Having the most significant bit as unset would be highly would not be as beneficial to us as having it as set. We can have the lower bits unset, but having this bit set would be more beneficial to us. So if that is clear, I can say that if I have some bit set in the XOR value, disturbing that would only decrease the number of bits that are set for the coming bits. I'll repeat myself. So, say if I have this bit set and I decrease this value, if I break this into, let's say, 2 power I minus 2 times 4, then these bits would increase by 4, but this bit would decrease by 1, and that would not be a beneficial case for us. So for each set bit, we do not have to disturb the bit. Now, when I have this array, I move on from the highest set bit. Since choosing the highest bit would allow me to break it into more and more parts, which would in turn help me to set more and more bits. So when I come on to see this 0, I can see that its frequency is 0. This bit never occurs in any element. So I cannot break this bit in any manner. So I have to move forward. I cannot do anything. Again, I do not disturb the 1. And when I come across the 0, I can see that it occurs 4 times. This bit occurs 4 times. So what I can do is I can take out one of these bits and break that. You can see that if I have something like 1 0 0 0, I can take this 1 and split it into all of the previous bits and have one bit remaining. So uh, what I can do is break it into two parts such that one part has these bits set and the other part is just a single element one. So each of these bits would be a single element which is a power of 2. If that is clear, when I come across this 0 and I see that this has 4 occurrences, what I can do is take out one of the occurrences. So this becomes 3 and that would make this bit set. And now with this occurrence, I can use to set all of these zeros. Since 2 power, let's say this is j. So 2 power j would always be greater than sum of all powers of 2 that are less than j. So having said that, let's try to see how we're going to break this. So now we have this bit and we break this. So this becomes occurrences 3. We increase the occurrence of this by 1. So it becomes 1 and the occurrences become 7. We increase the occurrences of this by 1. So it becomes 1. Occurrences 3. 1. Occurrences 1. Now we would have some values remaining. So let's say this is 2 power 7 minus 2 power 6 minus 2 power 1. So when I broke this bit and used all of these to make these bits set, what I have, the value remaining is something 64, 128, 64 minus 16, 17, 16, 48, 47. Sorry, 46. Yeah. As you can see, the subtractions that are happening are all powers of 2, so they're bound to be even. The topmost number is also a power of 2, so that again is even. And we can always split this into two powers. Say 2 power 7 can be split into 2 times 2 power 6 or 4 times 2 power 5 and so on. So when I identify this, what I can say is that whatever the number is remaining, that was going to be even, and that can all be utilized in the ones place. So uh, when I have utilized all the bits, whatever bits are remaining can be utilized as 1 plus 1 plus 1 plus 1 up to 46. And since this will always be even, the XOR of these values will come out to be 0 and hence not disturb our answer. I know it's a bit complex to understand it in one go. I recommend you can rewatch this video. But yeah, we can split the zero into, sorry. Yeah, we can choose this bit having set the value as 0, and we can split this into powers of 2 such that we have all the previous bits set and this bit sets as well. Now, I hope it's clear why I said that deleting an element was not required, because actually what we are doing is choosing only a single bit from a single element. When we choose the 0 to be disturbed, what we say is take the highest element, having this bit set. So if the element were 2 power, let's say this is j, k, l. So if the element were 2 power j plus 2 power k plus 2 power l, I would only break the j part and divide this into 2 power, I don't know, m, n, o, something. But I would not disturb k and l. That's why by dealing only with the bits, I can solve this question. And hence the time complexity would also reduce, as I do not have to delete every element and append elements and check for each case. So that is the approach for this question. If that's clear, let's move on to the code. So I've taken the number of test cases and created a solve function to solve that. Taking the input vector, also I've taken this x, that is the XOR of all elements initially. Now I've taken this flag variable t that helps me identify whether I've chosen an element which is to be split or not. If you read the question, it has been given that the power of 2 can be at most 60. So I start from 60 and I initialize a variable count. This whole process is just counting the frequency of the bit I. So in each element, if the bit is set, I increase the count by 1. Now count stores the frequency of ith bit. What I'm going to do is see if count is an even number. Because if count is an even number, the XOR value is going to be 0. And also the count has to be greater than 0. Because if there are no elements that have this bit set, we cannot break this bit. So if the count is greater than 0 and it's an even value, then I set the flag variable as 1. Now, whenever the flag variable is 1 for all the coming bits, I can just append the bit to my XOR answer. And finally, I return the XOR value. That is the whole approach to this question. Let's try to run it. Seems to be working. Yeah. So we've received a correct answer. Let's analyze the time and space complexity for this question. Okay, so we're not using any extra variables. We're not using any extra array. We're using some extra variables that is just constant time complexity. But what we're doing is for each bit, we're traversing the whole array. So that would make the time complexity as big O of 60 times n. That is the number of elements in the array. Given the time constraints, this is still an achievable time complexity. Hence, this is a valid solution. That's it for this problem, guys. Thank you.
Coding Club.